Everybody, here's something to think about. We know that the acceleration of an object when it's coming down an inclined plane, or rather sliding down an inclined plane, is g sine theta. But what about if it's a sphere, a disk, or a cylinder that is rolling down an inclined plane? So now instead of sliding down, what if it's something that's rolling down the incline? Will its acceleration still be g sine theta? I don't think so. Because now you have rotational motion together with linear motion. So let us try to find the acceleration of an object rolling down an inclined plane. I have a nice picture of the setup here, where you have this sphere that is rolling down the incline. The forces acting are the weight mg acting vertically down, the normal force perpendicular to the surface, and friction opposite to the motion. So since the sphere is rolling down, friction would be opposite to its motion, which means up. Now, as you know, we need to resolve this weight into its two components, which will give us mg sine theta and mg cosine theta. And therefore, when you look at the net force along the x-axis, there are two forces. One is mg sine theta down and friction up. Therefore, the net force along the x-axis would be mg sine theta minus f, which should be equal to mass times acceleration. Remember that we are trying to find the acceleration, but we need to substitute for this force of friction. In order to do that, let us consider the torque acting. Torque is defined as I times alpha, where I is the rotational inertia and alpha is the angular acceleration. But torque is also given by force multiplied by the perpendicular distance. So the force of friction multiplied by this perpendicular distance would give you the torque acting about this axis. Now that's the center of the sphere is the axis of rotation. So since we have two formulas for torque, we can set them equal to each other, from which we can get an expression for friction, which is going to be friction is I alpha by r. But we know that angular acceleration alpha is linear acceleration a divided by the radius. So now we can substitute that in place of alpha and then get f is equal to IA by r squared, because there are two r's there. Now substituting this back into this equation, we have mg sine theta minus IA by r squared is equal to ma. So there are two terms with acceleration. We bring them to the same side, separate, take the a out, and then on the right side we have mg sine theta. So now make a the subject and we have our formula. We have mg sine theta by m plus I by r squared. Now this is a general formula using which we can find the acceleration of any object rolling down an incline. Now if it is a sphere, we need to substitute the value of rotational inertia of a sphere. As I'm going to show you here, that is the general formula. And if imagine that it's a solid sphere, And we know that for a solid sphere, rotational inertia I is 2 by 5 mr squared. So plugging that value in place of I, the r squareds get cancelled, and we can now in the denominator pull out that mass out and cancel the masses. We get g sine theta by 7 by 5, which can be written as A is 5g sine theta by 7. Now in the same way, we could find the acceleration of a disk. The only thing we have to do is got to substitute the rotational inertia of the disk, which would be mr squared by 2. So we can use this general expression, this one, to find the acceleration of any object rolling down an inclined plane. I hope that makes sense. Enjoy and have fun with physics.